now, we're going to talk about endangered species. And the notes kind of look the same. Like if I take notes from one class and the other, they're easy to mistake. Because I'm going to go over some common characteristics and some causes. And so, please make sure that you title today's notes Endangered Species. I'll be using this high-tech technology of the past. Nothing but the coolest, newest stuff for you. And I'll warn you, it's kind of tough to read sometimes, this overhead material. So, are you ready to go?
Yeah.
Do it.
Okay.
The nice thing about the overhead is we can all kind of stay on the same page. So let's all start with causes of extinction. The College Board has basically asked this exact question, like what are the leading causes of extinction, at least 2 or 3 times. And I gotta point out, first and most importantly, extinction is totally natural. It happens all the time. Not a big deal. 99.9% of all the species in the history of life are already extinct. We are seeing a momentary blip in the history of life on Earth. Almost everything that's ever existed on our planet is already gone, extinct entirely, never to be seen again unless you believe Jurassic Park. Because, you know, there are losers in evolution. We call that natural selection. Sometimes, you know, 2 species just kind of come together and one is better than the other at doing that niche. So you can get what's called competitive exclusion, where one species just gets kind of kicked out by another. And sometimes environments change. You know, the wind changes direction, the lake dries up, a rock falls and it changes the habitat. It's funny, we get so stressed out about some extinctions that we forget how utterly ho-hum extinctions are. Extinction is kind of all the time. And every now and then, it even goes off like big time. Like big time, big time. Pretty much, these are all catastrophic. Climate change. There have been 5 mass extinctions in the distant past. 5 of them. If you could please look up over here. You've seen this before. I keep pointing at it. This is the timeline of life on Earth, starting with single-celled, and then multicellular, and then the invasion of land, and then the invasion of the air, and then the age of the dinosaurs, and then the second dinosaurs, and the age of the mammals. Please look up over here again. If I'm not mistaken, meteor, volcano, meteor, volcano, meteor. And if you want to correct me on that, I'm happy to be wrong. I'm just kind of like shooting from the hip. That sounds plausible. But they've all been meteors or volcanoes that change climate.
So a volcano changes climate by releasing ash? Or is it just...
Usually we have some combination of multiple factors. You tend to get a lot of suspended particulates that dim the sun, so productivity drops. So that's ash or dust, or in many cases like ocean deposits, silica sand. And also they can precipitate changes in ocean currents because of CO2, warming, currents stop mixing, ocean die-offs, and usually some shift in atmospheric composition. CO2 or sulfur oxides or other stuff I don't know about. These are catastrophic changes. And when you think of a mass extinction, you think of something sudden, like the meteor that killed the dinosaurs. But here's the crazy thing. That's not that sudden. In a mass extinction event like the meteor that killed the dinosaurs, there was probably a dinosaur where the meteor hit. Like some dinosaurs were actually like, oh my god, like died from the... And then, you know, a couple of them probably died from sudden shifts in ecosystems. But I have to remind you that these are like a snowball effect, like dominoes. One species dies, and that means the habitat is missing for another. That means the pollinator is missing for another. That means the seed source is missing for something which fixes nutrients in this. So it's all these gradual, like, pins falling one after another. And mass extinctions are usually like a couple thousand years long. It's not nearly as sudden as we used to think. When you watch documentaries on TV and they talk about the dinosaurs, it's like, boom, the dinosaurs are gone. And it's really not accurate. I'll tell you later, this is the most rapid mass extinction event in the history of life on Earth right now. And that's not that rapid. Watch. You can call it the base level extinction, also known as the background extinction rate. And if you just average out the history of life, it's 2 species per year, roughly, depending on how you define species and whether or not you count bacteria. In other words, if we just leave the planet alone and nothing else is happening, the background level extinction rate is 2 per year. Yeah?
Does that mean that there's a background level new species extinction rate?
There does. And the average seems to be about 2.01, just slightly more. So the total number of species on board seems to have slightly grown in the history of life on Earth, but not very much. You know, evolutionary novelties create new niches, but not too many. Now, first I wanted to make sure that we all agree that extinction is natural, but you all realize the reason we're talking about this in an environmental science class is because we speed things up. We add extinctions. There's all the natural ones, and then there's all the stuff that you should feel bad about. Connor, I love how you gravitated toward Chase. It's like so adorable. Nobody likes anybody that much. He's so flattered, bro. There's like the most beautiful babes and hunkiest dudes, and nobody sits next to them. Check you out, man. You're like a magnet. All right. I've got a really handy acronym for how humans cause extinction. So I'm going to build an acronym for you. So you might want to start like a bulleting thing. First, Humans mess up habitat, that's the H of our acronym. And whether the habitat is entirely lost, or most of the time, it's developed or fragmented or somehow deteriorated. Sometimes the relationships in the habitat go away. How many of you have already completed the endangered species assignment? Whether you're in this period and got it stamped or not, how many of you have already done that assignment? Okay, now, how many of you have a species which is endangered primarily or secondarily because of habitat issues? Please look around. This is how we are destroying so many species on our planet. First and foremost, we affect every habitat. We change the chemistry and temperature of water, we remove species from the ocean, we add all kinds of trash and miscellany into our fresh waters, we bulldoze and mine and light on fire and cut down pretty much everything. Kind of amazing, like if you were an alien watching the Earth, this human thing would be really, really amazing. Like, oh my God, look at what those things are doing. If you don't mind, I want to teach you something that is probably Environmental Science 102. Maybe ahead of the AP test a little bit, but it's a fascinating thought. Don't start copying. We got to think for a minute. So don't copy this, but it's called the species area effect. And I'll talk about this, so don't start copying. I need to explain one of the most fascinating things about habitat loss and biodiversity. This is over the heads of a lot of my colleagues and a lot of people who teach ecology, and it turns out to be, I think, one of the most obvious but not obvious things about environmental science. So give me a minute to explain, then you can copy. We'll have time. Look, this is the percentage of species left. This is the percentage of habitat that has been lost. So if you've lost no habitat, you should have all your species. And if you've lost all the habitat, you'll have none of your species. Does that make sense to everybody? Percentage of species left, percentage of habitat lost. Here's what's interesting. It's not linear. If we lose 1/2 of our chaparral, we do not have half of our species left. Imagine if this classroom is the California chaparral, and we develop half the chaparral, would we lose half of our species? You understand we would lose half of our biomass, right? We cut down half the trees and we lost half the mice, right? If you lose half the habitat, you've lost half the individuals. So far so good, right? Give up half the chaparral, you've lost half the things that live in chaparral. But in the remaining half, you probably have most of the species represented, right? The only species you've lost are the ones that only lived on this half by coincidence. If you had the right side of the room mockingbird, and you've lost the right side of the room, hey, we lost a species. But in the chaparral, most of the mockingbirds will live in both of those areas, so you lose half the land, you don't lose half the species. You understand the difference between a species and individual, right? Mm-hmm. We're all Homo sapiens. If I kill half of you, we've lost half the individuals, but the species is still here. Here's the interesting thing. Habitat is most valuable when it's most rare. Habitat is the most valuable when it is the most rare. Think about this, just abstractly without writing notes. You don't need to figure out stuff for environmental science, just think about what this means. If you've got a whole bunch of tropical rainforest and you lose 1% of that habitat, meh, all the species live in the remaining 99%, no big deal. Biodiversity isn't impacted, we just lost a little habitat area. So little. Is that like a full normal age human? Anybody know how old that human is?
11.
That's what I thought.
Okay.
Is that an exchange program from the 4th grade? Imagine if you've got the last 10% of the tropical rainforest. That's like the life raft for tropical rainforest species. If we lose half the chaparral, we still have most of the chaparral species. If we lose another 30% of what's left, we still have most of the species. If you get down to that last little smidgen of chaparral, that's probably the last individuals of a whole bunch of endangered species. Here's what I mean to say, now you should start to copy. You'll have most of your species left until you reach that life raft moment, and then every last little smidgen of habitat loss is devastating for diversity. It's not a line. This is non-linear. It's not proportional. The species area effect. Chase, could you pass up a water bottle, please? The species area effect says that habitat types have the most impact on diversity when they are the most rare. Land is more valuable as the habitat type becomes more scarce. Was your hand up?
Oh, I was just gonna ask, is that, if it's like a life raft moment, is there an actual point? Some extra things declared? This habitat is super bad.
Well,
Is that just
yeah, I mean, there's like equations for genetic viability for a species. Like 2 individuals is usually not good enough because then you're just going to raise a bunch of inbred babies that are all siblings to each other. So there's like some critical numbers to maintain genetic diversity, and that depends on how big the genome is for that species. So for bacteria, it's like 7 individuals, but for something complex like us, it's probably in the hundreds or thousands. And so for different species, that's a different habitat area, right? The minimum viable habitat chunk for elephants would probably be a huge land area. The minimum habitat chunk for Cyprinodon macularis, the desert pupfish, is like a horse trough full of water.
Is there a way to tell where we are, like globally, on this?
Well, that's an interesting question. You know, some habitats are a lot more scarce than others. So chaparral, where you and I live, like this biome, we're down to single digits. Coastal chaparral, like ocean bluffs chaparral, there's almost none left. Like honestly, there's the like Naples tract, and where's that one that somebody wanted to develop? Is that Naples?
Gaviota.
What?
Gaviota?
Yeah, the Gaviota, say the Gaviota Coast, all the butterflies, and like the, you know, the Hollister, like at the end of Hollister, the, what is it, Government Point, like Pascoha? Like those are some of the last acres left of that habitat. Like once those get developed, you're down to little tiny chunks. Like you might lose endemic species every time you give up an acre of those now. Some are more rare than others.
You have to go like ecosystem by ecosystem.
That's right, you have to go habitat by habitat. All right, we got our habitat loss. Questions about the species area effect? Next. Invasive species are a big problem. We spread stuff around and they displace natives. How many of you have a primary or secondary threat from invasives? If you look around, that's like 3 kids, 4 in our room right now, maybe 5. You already know the deal because we talked about invasives yesterday. If they can get a foothold in a disturbed environment, they can take off. There's 2 P's, so this gets complicated. 1 P is pollution. This is almost entirely for aquatic species. There are very few species threatened by pollution that are not aquatic. Raise your hand if pollution is a big threat to your endangered species. Aquatic, 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 aquatic. So there you go. Because all pollution becomes water pollution. Pollution is primarily a threat to aquatics. And don't confuse it with the other P, which is poaching, which is stuff that's illegal, we just can't stop it, like an elephant or a snow leopard. A lot of high school kids say, well, couldn't we just make that illegal? Because you live in a country where law and order is pretty substantial. But you know, you go into the backcountry in the Himalaya, you might be 100 miles from asphalt. It's pretty easy to kill something and not get in trouble for it there. Deep in the Amazon where nobody's watching. Middle of the desert somewhere. So poaching is a big problem. How many of you have poaching? Wow, that's kind of a lot. I'm surprised it's this many. Mostly mammals for their fur, right? Anybody have something that's not a mammal for its fur? What do you have?
Black rhino.
Oh, for the bone and the horn? Anybody else? Yeah?
Siberian sturgeon.
For the caviar? Yeah?
Super hornbill.
For the pet trade?
No, like, I guess their feathers and like their horns.
For adornment.
Yeah.
Careful you're not beautiful or we will drive you to extinction. Pays to be ugly. And over harvesting. We gotta point out that this is not, it's a lot like poaching. This is just either not well regulated or not regulated at all. Ooh, you gotta go. Glad we checked. Bye.
Yeah.
What does it say next to pets?
That says food, fur, pets, bycatch,
Bycatch.
like stuff that we kill by accident when we're trying to catch other stuff. Or industrial overharvesting, like some trees that we cut down and things like that. Yeah. There's a lot of cold tiles. Whoa. Miller's little mind is blown. Hey, here's a cool vocab term for you to know. A weird type of overharvesting is that hungry people in remote places eat whatever's around. Like the way I might eat a raccoon if I was hungry enough, or a cat or whatever. And you know, as the world's poor are forced to expand the footprint of their cities, they just eat whatever's in the trees right next to their homes. This is called bush meat. It's a strange type of overharvesting, which is just plain old hungry people. Like you just eat what's around. Hunting and gathering. This is kind of an interesting subject. You know, a lot of us Western people, we believe incorrectly that the world's less developed humans must be environmental saints. There's this mistaken notion of the noble savage. The idea that Native Americans lived in perfect environmental harmony or whatever. And nothing could be further from the truth. There was very few of them, so they didn't have a big impact on the environment. But you can correct me if I'm wrong. I can't remember if it was the Hopi or the Apaches. But they used to storm entire herds of buffalo off cliffs.
I think that was the Apaches.
The Apache, and they would just butcher a few off the top. Can you imagine killing like 2,000 buffaloes to feed like 12 people? In the Amazon rainforest, some of their favorite foods are these like really rare birds and like really beautiful monkeys. And whatever, people gotta eat. And back in the day when there wasn't a lot of people, that wasn't a big deal. But nowadays, we consider this a type of over-harvesting where just people eating what's in their neighborhood, in some cases, is driving extinctions. How many of you have an over-harvesting extinction example? Curious, just say the name really quickly.
Sawfish.
What?
It's a type of toad. I forgot the name.
Pudding frog, called pudding frog.
Yeah.
Why do they harvest those?
For pets.
For pet trade?
Yeah.
The Dendrobates genus?
I think so.
Dendrobates? Anybody else? Yeah?
They use the Yosemite toad skin for like stuff, like leather.
No kidding.
Yeah.
My daughter found a Yosemite toad last summer. It was really beautiful. All right. Hey, look. If you make that into an acronym, you get HIPPO, hippo. Which, ironically enough, is an endangered species too. Habitat invasives, pollution, poaching, and overharvesting. Make sure you get that distinction between the P and the P, and between the P and the O. Poaching is illegal hunting. Overharvesting is just poorly regulated or not regulated at all. Make sure you get that distinction straight. Now, hippo is the current problems. But over the next 20 years, we're going to start seeing more and more of a new problem, climate change. Look, in the future, it'll be climate change. Hippo is now. Your kids will say chippo. Because climate change will be on top for your kids. And climate change is going to wipe out a lot of species. But not for the reasons that you think. And this is a critical distinction. This is bound to be important the rest of your life. The planet is about 1.5 degrees hotter now than it was 150 years ago, and nobody cares about 1.5 degrees. Let's be really clear. You all know what happens when a polar bear's environment goes up by 1.5 degrees on average?
Some of them die off, probably.
They're pumped. They love the heat. Can you imagine being a mammal in the snow? They love it. Of course, it's not the heat that's driving them toward extinction due to climate change. The polar bear was the first species listed endangered because of climate change. Yeah. The polar bear was the first species listed endangered because of climate change. But it's not the 1.5 degrees, it's that the environment changes. At 1.5 degrees, sea ice doesn't last as long, so they get a shorter breeding season, so the polar bears can't get fat enough to nurse their babies to weaning. It's not the temperature, it's the way that the system changes. Here's a fancy example of climate change causing extinction. We've got a bunch of migratory birds that have started their migration earlier or later. So what that means is they'll land in a feeding area before the food is ready. So the temperature doesn't matter, they adjust, but their ecosystem falls apart. The flowers open before the pollinators hatch, and they both go extinct. It's not the temperature, it's the timing and place don't line up anymore. Climate's always changing, but it changes slowly. When you change it all at once, the ecosystem relationships don't survive. There's a term for this. Please look up, it's hard to see. That says ecosystem shear. Watch my hands. Watch my hands. Remember all of those relationships that didn't fit in the food web, the community level interactions? Imagine if every one of those species survives the temperature but doesn't connect on timing, or doesn't connect on the same part of the map anymore. Birds are migrating north, uphill, and at different times. Flowers are blooming earlier. Insects are migrating downhill in some cases, uphill in other. The relationships fall apart. That's called ecosystem shear. Climate change won't kill anybody because of the temperature. It's the wrong problem. It does not get too hot for anything. The moths can take the heat, and the crickets can take the heat, and the rhino can take the heat, and the agave can take the heat, and the trout can take the heat. But the relationships don't work anymore. Haven't you noticed all this amazing timing in evolution? Where like the salmon come uphill right at the right time for the bears to get pregnant to raise babies? That's no coincidence. That's just the only way that they could succeed in this long period of evolutionary adaptiveness. Now it's just like, boop, stuff doesn't line up anymore. Ecosystem shear. If you add all this together, the anthropogenic extinction rate, there's a new word for you. If you know your word roots, please look up. Caused by humans, anthropogenic. The extinction rate, which is caused by humans, is somewhere around 100 to 1,000 times greater than the background extinction rate. So today we think we're losing somewhere between 200 and 2,000 species a year, most of which we don't even know about, because the majority of our planet species have yet to be described. Yeah?
So for the realigning of these species in terms of timing, that happens after one of these natural disasters like a meteor or a volcano, that just takes an incredible amount of time and a lot of it die off.
I want to get back to this question later. I'm going to only barely answer it, but I want everybody to hear it. Homeboy says, for the realigning of all these relationships, does that just take a long time? And the answer is yes. That's why specialists always go extinct. The generalists survive mass extinctions, the ones who don't have a lot of connections. They're generalists, they're not too picky.
So we're just going backwards in that.
And then specialists evolve over time. You'll see, I've got a slide for this. At the very end, I hope we have enough time for me to really give you a better answer. And I want everybody to see that answer as part of my plan today. Yeah?
Are deep ocean, like, life, is they vulnerable to this type of thing? Like, I know the book talked about how fishing is getting more advanced, but is overharvesting affects deep water life?
We are increasingly fishing in deep waters. When you say the bottom of the ocean, if you mean the bottom of the deeps, we don't really fish there. reach a couple thousand feet for most commercial fishing.
But there's ecosystems down there.
There are.
Do we think that they're like completely unaffected by this type of climate change? Or?
Well, it's tough to be sure. The ocean is changing in ways that we don't really understand. Because a lot of those temperature exchanges within deep water circulation are practically impossible to map with current technology. It's really tough to know how heating in the atmosphere and the surface is affecting those deep currents and thus those habitats. We're not really doing a lot of these other things, but we are degrading the deep ocean habitat by changing the chemistry. So check this out. Because we are at such an elevated extinction rate, there's a name for this extinction. It's called the current epic extinction. That's you and me. Holocene is now, and the Holocene extinction is us. Remember, it was meteors, volcanoes, meteors, and now it's humans. Look at my poster. Look over here. See that yellow sunburst? Describes whatever that was. And then there's another mass extinction. Here's another one. Here's another mass extinction. Here's another one. And look over here. Look. That's right now. We are the 6th mass extinction.
Look at like 21. What does that say?
We're going to lose about half of our planet's species by the year 2100. So believe it or not, that's the fastest extinction in the history of life on Earth. We're the biggest eraser.
So does that 50% account for possible species that provides for an influx in the species that adapt? Or is that just if nothing else changes?
Well, these wouldn't happen at the same time. Extinctions are followed by speciation. We'll talk about that later. But right now we can say with some really high clarity that a significant number of our planet's species are pretty distinctively doomed. We're down to just a few examples of many of your endangered species, and the IUCN Red List is growing faster than we can write it. In most countries, we don't even have the money to keep track. So it's kind of a lost cause. A lot of biologists will show up in some remote part of Indonesia and go like, hey, how's it going? And they'll be like, oh wait, those are gone, those are, and it's like, oh crap, it's just too difficult to keep track of them all. It's kind of cool to think of who goes extinct. Because you know, some species are not going to go extinct. Some species are really fragile, like they were kind of doomed anyway. Like even before we came along, like all the big stuff. You know, it's really tough to be a big animal because you need a lot of habitat, you reproduce slowly. You know, a long lifespan between generations means you gotta survive 30 years of good luck before you can make a baby. So big stuff is more likely to go extinct than little stuff. You know, if I had free reign and nobody to stop me, I could probably kill 1,000 elephants in a decade. I might be able to kill 1,000 elephants in a year if I have enough technology and helpers. And that's like all the elephants. But no matter what I do, I couldn't kill 1,000 guppies in a stream. And even if I did, there's gazillions of guppies in a stream. So being big, they're just the first to fall. You know, that was true of the dinosaurs too. The second round of dinosaurs was smaller than the first round. Being big sucks. You know what else sucks? Being useful to humans. So we haven't figured out how to eat jellyfish, so guess what? Global populations of jellyfish are exploding because we can't use them for anything. So we just leave them in the water like, nah. We just kill everything else around them. So the jellyfish get to eat up all that productivity, and now they've got no predators or competition. So jellyfish are like swarming the world's oceans. We hadn't figured out how to eat ants yet. So the ants are definitely safe. As soon as we decide to start eating something or using it, it's doomed. It's like, oh, look at that pretty cat. I want to wear it. And then there's no more snow leopards. Or like, oh, panda bear. I'll bet you it's helpful to like grind up its testicles. Or whatever, or its spleen, or eyebrows. I don't know what you grind up on a panda bear. But God forbid you're useful or sensitive. You'll notice I'm pretty much describing specialists, right? Hypersensitivity, specialization in general. Like, if you need quiet, you're doomed. If you need darkness, good luck. If you need really clean water, game over. There's so many species that have honestly like really limited chances of surviving anyway. As soon as you change the ecosystem, all the specialists die. Like if you're a moth that only eats the pollen of one flower, you know, that's a pretty risky niche. So the specialists go first. How many of you have an endangered species that's very specialized, by the way? Can you just rattle off the names really quickly?
Tree cat.
Whale,
What?
whale something.
Whale fish?
Whale finch. Like
Finch.
whale something.
I just gotta realize it's not really that.
Hi, anybody else? Yeah?
Catalina, what is it called?
Can't hear you.
Catalina, what is it called?
Do you understand why it sucks to be a migratory species? You need twice as many or 10 times as many or 20 times as many places to stay intact. Like we protect migratory habitat in the United States, but of course that doesn't mean we're gonna protect migratory habitat in Panama or in like southern Chile. So birds that migrate all the way from one end to another, they need this place to work, and then 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 this place to work. Quiet, Adam. Get it?
Are there any generalists that migrate?
Maybe, probably. Migration is itself a type of specialization. So I guess in that sense, no. Yeah.
Well, with my bird, if it were able to migrate, I feel like it would have a better chance of survival because where it's living, all the shade
Sure, like
and
an escape hatch would be sweet. But don't forget that migration is not flexibility. Migration is like having to catch the shuttle at all the right stops every generation for all individuals. Right? So they got to show up at the right time to breed and make their babies or their genes are lost. And then they got to go to the place where they have their babies, or otherwise it's rare to find an environment where you can raise a chick. You know what I'm saying? So like it's... And children, I'm sorry that we haven't discussed genetics. That'll be in the lecture on Friday. Connor, Chase, be quiet.
No, I think I gotta find you.
I got a new seat for you, buddy.
Where?
Outside.
You're not gonna like it. I wish I could explain this better. I'll try to give you a quick little conceptual intro to this. Remember that, well, are you all still writing? I'm gonna wait until you write, because I really gotta talk about this genetic. I might be able to squeeze this in today, and that would be smart, I think. So I'll wait a second while you write.
What's the word next to genetic isolation?
It says bottlenecking, and I'll explain what that means in a minute. Okay. Remember that all species have variation. There's a lot of individuals, they have sex, so they scramble the genes. So pretty much all species have a lot of variation. So if you're on your cell phone, I will smash it against your face.
Never use that one.
You already used that cell phone. Touche. Maybe it would help you if you just put the cell phone someplace else since you can't discipline yourself. How about further?
I take it.
It's in my backpack.
Miller. Give it to Miller. Unlock it and give it to Miller. No, you don't have to unlock it. Miller, you can credit card it.
Yeah. I just took a test for like 3 hours, so that's my cell.
I credit carded some kid's cell phone once. Consider this your formal warning. Okay. Here we go. There is variation among individuals. There is variation among individuals. So for example, you got some yellow ones and some orange ones and some red ones and some brown ones and some black ones and some purple ones and some blue ones and some green ones. Okay. Imagine that variation is not useful today. And it's not harmful. So a lot of us have genetic variation, which is not really helpful, but it's not really harmful. So within humans, you could be like this tall to that tall, and it's no big deal. Or you could be left-handed or right-handed, it doesn't really matter. Or you could have a widow's peak or not have a widow's peak, and it doesn't matter. You could have this shape or that shape, it doesn't really matter. But all of these are options which might become useful as the environment changes. For example, new species of predator moves into the scene. Being yellow is really helpful. It's a good thing there was yellow genes in the population. That species will survive. Or a new disease strikes all the colors except red because red gives you an immunity to that disease. Great, it's a good thing that there were some red genes in the population and the species will survive. Or vegetation patterns change and now being green is really helpful so that you can find camo under the plants. Green used to not matter, but now that you had the green genes, you survive. This is something you should probably put in your notes. Genetic diversity is like a toolbox. You're always ready for unique problems if you have a bunch of tools. Don't cross this line so that you don't show up on the webcam. Okay? So, My friend Diego and I were both handymen. Okay? You call both of us and say, hey, I want you to come give me a quote on this thing that's broken in my kitchen. Diego shows up, and he's got this huge truck. And he goes to like grab his clipboard for getting a bid, and he like opens the back, and you can see like, oh my God, look at all those tools. And he's got all the stuff to work on metal, and to work on tube steels, and to work on lumber, and to do like finished carpentry and rough carpentry. And he's got like a sewing machine back there and an arc welder. Jose shows up, and I'm like, yeah, I'm ready to fix your problem. I have hammer. You haven't let us in the house yet, but which handyman do you think has a better chance to solve your problem? If we don't even know what the problem is, who's got the best chances of solving it? Fool with the hammer or homie with all the tools? This is the point. In evolution, even if your genes are perfect for today, that doesn't necessarily mean that you're ready for all the things that come up tomorrow. So cloning any individual doesn't really help, because in the long run, conditions are going to change. We need some other tools. It's called a genetic risk when you don't have enough genetic diversity. Genetic risk is when you don't have enough diversity. Who had the rhino? Somebody here had the rhino? How many, which rhino do you have?
The black rhino.
Java rhino? There's a few more Javas. How many black rhinos do we have left today?
Around 4,000.
How many Java rhinos do we have left today?
Like less than 100.
Less than 100, okay. Here's the wacky thing about having 100 rhinos. That's like one big family. You know what I'm saying? Like, if you keep breeding the descendants of those 100 rhinos, they're going to be pretty inbred. That's not a lot of genetic variability. That species is at a genetic risk. There's some rhino that we're down to 3. Like, great. We can clone them and make 1,000 copies, but if there's a new disease, it's going to kill all of them. Now, if it kills one, it'll kill all of them. We call that a genetic risk, when you don't have enough genetic diversity to survive changes in the environment. So you know who's likely to go extinct is small populations that are genetically isolated. Like if you just have grizzly bears in Yellowstone but nowhere else, that's a big species, but the ones in Yellowstone are doomed because they just have the genes of the neighborhood around them and just a few other individuals. If you take a population of humans and just skim off like 6 and say, good luck humans, you have to repopulate the world, those 6 are screwed because that's not a lot of diversity for humans. I'll explain what a bottleneck means later. And you know, not everybody goes extinct. Sometimes there's individuals left behind. If you take your list of who goes extinct, survivors are the exact opposite. Not big, not specialized. Useless to human is good. Stuff that breeds fast. The stuff that we call weeds is not going to go extinct. Look at how hard we have to try to kill rats. They're not going extinct. Look at how hard we have to work to get rid of those little tiny black ants that are in every one of our kitchens right now. Those little tiny Argentinian ants, the little black ones. Those will never go extinct. Crabgrass, not going to go extinct. You know, the weeds and stuff. They tend to be smaller. They're fast breeding. They're common. They're really tough. You know, they're generalists. They're not picky about where the weeds grow. They're not picky about what you feed the ants.
What's after omnivores?
Low on the food chain. Yeah.
Does that mean in 2100 when all of the, like 50% of our species have been extinct, the rest are just gonna be like gross, like pests and stuff?
Almost everything that you call a pest or a weed today will be among the remaining 50. There will also be a lot of stuff that you just don't necessarily think is gross, but we haven't necessarily hunted or harvested the heck out of either. You know, there's this term in evolution, the species that stick around, that have kind of been here more or less unchanged for a really long time, they're called relics. They've made it through a whole bunch of mass extinctions. Centipedes go back more or less unchanged for like 400 million years. Crocodiles and alligators, sharks. Yeah.
Sharks don't fit a lot. I mean, crocodiles don't. Sharks especially don't fit a lot of things on the list. They're not that small.
It's kind of interesting to point out that there's a whole bunch of sharks. And so you're right that some sharks don't fit those, but the majority of global biomass of shark is the smaller, faster breeding, more generalized of the sharks. So, you know, you're right, great white doesn't fit that.
So they're like.
Think how many black tip reef sharks are out there, or white tip reef sharks, or nurse sharks, seven gill sharks. Yeah.
What about like
Leopard sharks.
what about like bull sharks that are really generous because they can do freshwater and saltwater? Would you say that they have a
You got a better chance, right? They're less picky than white sharks. They probably reach a reproduction age earlier, so they have to remain untouched. They have to have good luck for less time. Like anybody can be lucky for a few minutes. So I think a bull shark, you know, if it breeds earlier and eats more stuff in more places, is more likely to survive. Yeah.
because they are pretty big.
Yeah. Yeah. I mean, some big things do make it. Crocodiles are really big. So let's see if we can't get back to what I think is kind of the trippiest big picture part. I'm going to start drawing from the bottom. So you might need a whole sheet of paper or at least like half a sheet. And you don't need to draw all the details I have. You don't need to draw as much detail as I have. I don't care how you do it. Oh yeah, from the bottom up? I probably would. I would. You don't have to. All right. So it's cool to take a slightly longer term view on this. You know, we're living in a pretty depressing moment for biodiversity. If you feel overwhelmed with all these bad news, you can join the club I feel bad too. It is unfortunate, you know. I grew up loving biology. I was really excited to go out and chase birds and lizards when I was a little boy, and I'd like my kids to see all the same diversity that I've seen. But honestly, I realize that by the time they go diving, it's going to suck more than the time that I went diving. Like, if they wanted to spend their life bird watching, they're going to see less birds than I could have seen in my 40 years. So it is depressing. But you might feel better if you just consider that, well, it's happened before, and there's going to be some life. There's these neat patterns. Look, in the beginning, there was very, very few species. These lines show species. And look closely, because I want to move this paper just barely. At some point, a species might split. So now we have two. And sometimes, when single cellular life becomes multiple cellular life, that opens up a bunch of possibilities. You could be a surface water algae, a deep water algae, a mid-water column algae, a saltwater algae, a freshwater algae. So you get these things. They're called punctuated speciation. When you look at the history of life on Earth, there will be like a few mammals that survived the dinosaur extinction, and then bloop, whole bunch of dinosaur species. Punctuated speciation is like a whole bunch of speciation at once. Please look up here. Excuse me, please look up here. When the first life came onto land, that's not a single species niche only. When life shows up on land, you have the potential for, I don't even know, hundreds or thousands of niches right away, right? Because you could be like the little thing on land, or the jumpy thing on land, or the dig a hole thing on land. Or you could be the one that eats the other things on land, or you could be the really big one that moves slowly on land. And so you realize that when life moves onto land, that opens up a whole bunch of niches. Now please look up again. You can see how many, because of this light yellowy, light brown color kind of sprawling out. That's what percentage of life on Earth was terrestrial. So it used to all be aquatic, and then boom, new idea. And pretty soon, 30-40% of the species on Earth are terrestrial. Ditto a few million years later, when life in the air starts, all of a sudden, that becomes what? 20, 30, 40% of all species live in the air. That's this, punctuated speciation. And you know, sometimes a species will go extinct because its niche is overwhelmed by another individual. This is competitive exclusion, where some new variant does better than some old species, so the old one goes extinct and a new one replaces it. Hold on. So this is competitive exclusion, where a competitor excluded that one. It's extinct there. Yes?
So what lets punctuated speciation happen is just a lot of habitats that are unused.
Niches that are unused.
Right.
Yeah. As long as there's enough productivity to support multiple species, competition always hurts and they'll specialize to avoid competing. Imagine a bell curve of distribution. The ones who are most like each other have the most competition. So instead of being what's called stabilizing selection, you get what's called disruptive selection, where the two extremes don't even compete with each other at all. So these ones that have no competition have more fitness than the ones who are competing with. And so if there's enough productivity to support two separate populations, they'll split and become two different species. But you know, bad stuff happens. And imagine a meteor goes off and a bunch of stuff goes extinct at once, that's called punctuated extinction. Those are the mass extinctions. Punctuated speciation is mass speciation. Punctuated extinction is, mass extinction. But there's always a couple survivors. And whoever survives will again diversify to fill empty niches. That's a lot of lines for you to copy. Don't stress too much on the lines. You'll get the idea, but please look up here. I need to point something out. Remember that when the meteor killed off all the dinosaurs, there were a couple of species that survived. You might know that a small tree mammal survived and gave rise to the age of the mammals. You know who else survived? Some wacky little funny looking dinosaurs that had weird scales that were kind of feather-like. And with all these open niches, all this productivity that wasn't being consumed, you had this speciation event of the age of birds, too. So when you knock off all the dinosaurs, sucks to be a dinosaur, but that's going to leave a lot of jobs undone, so mammals can diversify and birds can diversify, and you get the age of the mammals and the age of the birds. There's this kind of comforting balance called punctuated equilibrium. Where, yeah, you get some extinctions, but then you get bursts of speciation. And like, oh, I'm so sorry to see the dinosaurs go, but oh, cool, I do like narwhals and like hornbills. When you take the long view, those mass extinction events are really sad for the losers, but pretty sweet for the winners. And so, like, if you really like dinosaurs, that meteor is a big bummer. But if you're a mammal like me, then it's got a flip side, a little silver lining. So I've got some bad news and I've got some good news. I got bad news and I've got good news. Our lecture has bad news that I already told you. Probably half of our planet's biodiversity will be gone around the time that you get buried. You'll die on a planet with half the species of the planet you were born to. That's pretty amazing. That is probably the most severe mass extinction event in the history of life on Earth. It's more rapid than those. Remember I told you those take thousands of years? This will be a 50% reduction in global biodiversity in about a century. That's stunning. That's the bad news. We are the worst mass extinction. You know, we're really good at being human and we're really changing the planet. Hippo. And I don't know, like, that sucks, but you didn't expect to live forever, right? So, like, I don't know, we don't think about it a lot, but mortality is sort of an unavoidable reality that we should probably be sensitive to, but also realistic about. You know, we try to live as long as we can, to have as good a life as we can, and then, you know, someday or another, it's over. Hopefully no time soon. Don't do it. Your mental health is important. People love you. But all the species are not going to last forever, and neither are we. And I always wonder, with 50% of today's species gone, who's going to make it? And then, what's it going to be like in 10 million years? That trips me out. Jellyfish, ants, eucalyptus seems to make it no matter what you do. Red acacia, it's like a tree from the African savanna that's like taking over all of Santa Barbara. Ivy, cats will probably make it. God, I hate cats. But they'll probably make it. I won't. Jellyfish for sure. And then, you know, they're going to have one of these. Like jellyfish will diversify. And we'll have big jellyfish and little jellyfish and terrestrial jellyfish and flying jellyfish. That's so rad. Flying jellyfish. Or like giant oceanic cats. Like, I hate cats now, but if like cats filled in like the blue whale niche with like the big baleen, like nurse, like eating those big like gulps of krill, I might like cats. The punchline of this whole extinction lecture is you gotta really decide what you want to focus on. Just like everyday decisions in the rest of your life and your physical health and dating and all the other stuff, you gotta decide what you want to focus on. So here's a thought. In the long game, it'll be the age of the jellyfish and the age of the ants or whatever. In the long game, there's some other future coming. Okay. Can't fix it, can't help it, can't stop it, can't see it. Unless they freeze my head like Walt Disney. So that's cool, but too far out for me to think about. You know, if you think far enough, the Earth gets sucked into the sun in like 1.5 billion years. Well, who cares? That's too far out anyway. Doesn't affect us. I feel like that biodiversity is just really important for us. Like, we need all that stuff to like improve our water quality and feed our children. Like, we need biodiversity for us. So my priority is to just not make stuff worse. I don't know why I should value, what was your species?
Sawfish.
I don't really know why I should care about sawfish, but who knows, like, maybe they have some connection to salmon or to my kids' happiness next decade. So like, let's just try to save the sawfish. And what was your species?
The long clawed sawfish.
whatever that is, I don't even know.
Frog.
Frog? Whatever that is, I'm like, oh, okay, well, frogs are cool. Let's just save all the frogs. Because they probably have something to do with insects and flowers, and I don't really get it, but I just feel like rather than getting all persnickety about the stuff that we choose because it's pretty and reminds us of us, do you know that humans are like twice as likely to pay for the conservation of a species that has eyelashes? Rather than just picking the stuff that reminds us of us and they have fur and they lactate or whatever, I think that we should just try to like stop breaking things. Like just stop breaking stuff, man. Just don't wreck it. Like it's not gonna last forever anyway. Let's see. Push that door open. All right. Well, I think I'm done with that lecture. We got time for questions. Celine, could you, Shay, could you press stop streaming?